Thank you, Dan. Just to let you know, I'm Doug Marcy with NOAA, Ocean Service, Office for Coastal Management. I'm located in Charleston, South Carolina, and the reference for what Dan was talking about was in grad school. His roommate and I went and took some classes at NC State. Got my master's at UNC Wilmington, so crashing on the couch for actual academic purposes, not for partying purposes. Just so I'd like to thanks for inviting me. I think Amanda McCarty, we gave this demo to her, and she had reached out maybe to this group to let you know this new tool that we just had come out in December. We're pretty proud of it, and right now I'm just going to give you an overview. We don't have a whole lot of time to get into the details, but I'm just going to give you an overview of what the calculator does. And just to point out, it is sea level calculator. We didn't put the word rise in there, maybe for obvious reasons, but because there's some places where sea level is actually going down as well. So to start out with, just going to give you kind of an overview of what the look and feel of the calculator and some of the functionality. And if there's any questions, follow up. I'd be happy to do more in-depth demo or answer any questions. So just to show you the front page here, the way this works is you kind of scroll down. This gives you kind of an overview. We're providing information for different sort of variables of water levels to give you information about the current, well, the past, the current, and the future flood situation and water level information, both at NOAA tide gauges, but also projections on a 1 degree grid from the 2022 Sea Level Rise Tech Report. There are quick views. There's 5 of them. I'll go into that. This just describes each of those. We also have right here, you can access all of the data. Right now it's just a PDF document, but this is pulling in all of the co-ops, which is the Tide and Water Levels Office, all of their APIs that we're pulling in for the calculator, and all the map data. So all the data that you can see in the calculator can be accessed here. Through this partnership, this is really a collaboration between our office, OCM, Office for Coastal Management, and co-ops. We're really trying to make the co-ops water level information and products easier, combined with some of the mapping products that we do in our office to communicate flood risk in the future and flood frequency. And we're continuing, the idea here is to continue in the research realm and try to add more gridded data in the future as we go through and try to do that through the modeling efforts that are going on. There's frequently asked questions here at the bottom. You can go through all of those just to give you an idea of what's on there. So the way this would work is you just go into a location. I'm going to go with my favorite since I'm here in Charleston. And you just click on the location there. What I'll do is I'll scroll out so you can kind of see the lay of the land here with the maps. We have all of the NOAA tide gauges in here, the long-term gauges, but also some of the other subordinate gauges that may or may not still be around, but there is data there. So you can see those, and the 1 degree grid. And again, this is the grid from the 2022 Sea Level Rise Tech Report for the projections. So if you're in between gauges, you can still get projections at these locations. Now, I know they go farther inland. That just happens to be the grid that they produced in the report. But it is the first time we were able to actually provide gridded information. And we're going to try to do that in a higher resolution for flood frequency in the future through some of our coastal ocean reanalysis program that we're working on. So the way this would work, you just go in and you click on the Charleston gauge. You'll notice here on the legend that the larger buttons here have all 5 quick views. That's because they're long-term gauges. They have all the data. Some of the other smaller ones don't have as much data because they may be subordinate gauges and not around anymore. So the way you do this is you click on the gauge, and it tells you right here, Charleston, South Carolina, it has 5 quick views, and the period of record for that gauge is 1900 to the present. Then you're presented with these 5 different quick views. I'll just tell you that each one of them on the back tells you what information you can glean from that quick view. And there's a video, and I'm not going to play it because we don't have a lot of time, but each of these has its own little video that tells you what you're going to see in that quick view. And I can actually point you to where all those videos exist if you want to use those. But the video will just pop up in your browser and it kind of tells you that. So I'll go ahead and go into future sea levels. And what you see, the kind of the general layout of the calculator is all of your, it has sort of a main graph, and you see that here, and you have your variables over here, which you can kind of change your settings. So what you're looking at right now is the future sea levels for Charleston, South Carolina. So you can turn on and off all your variables in the graph. This is just using a typical high charts graphing functionality. You can zoom in, to the scenarios. And so what we're showing here is the regional observation extrapolation from the 2022 tech report out to 2050, and how that kind of lines up with the different sea level scenarios. At the same time, over here on the right, we have a map. So we're actually linking to our sea level rise viewer layers that we've done half-foot increment mapping. So anywhere in here, you can click on the graph. Reset zoom, sorry, click on the graph for some of the more extreme scenarios. It'll set your threshold, which is the red line, and show you that what will be impacted on the ground with that particular height or elevation. So that's pulling from a map library. So you have this sort of double binding between the graph and the mapping, and that's the first time we've seen functionality like that, and it's very useful to kind of see the impacts. The other thing we have is be able to change datums. So one of the things that I know engineers always want is mean sea level versus mean high water or NAVD. We've done all of those conversions for you, and you used to have to go to the tide gauge and get all that information based on the datums. We don't do that on the gridded data, the grid projections, because we don't have the VDatum model referenced there and datums, but you can go back and forth between datum. Just to be aware that all of the projections are referenced to mean sea level right now. So if you do your conversions, take that into account. You can also change whatever threshold you want here manually. So you can put 2 feet. So if you want to do 2 feet NAVD, for instance, put that in. You can change the vertical land motion rate, and this is based on the long-term rate from the gauges that were used in the tech report. But if you know there's local subsidence that's going is higher than that rate, then you can actually go in there and change the rate, and it'll change the curves based on that. Also, for engineering purposes, you can go back to 1992, which is the midpoint of the current National Tidal Datum epoch, and this will basically make sure that you're referenced back to that, which is what our current tidal datums are based on. And that'll all be updated when we go to our new epoch coming up soon. I think in 2027 is when we're doing that. Also, you see here that in the, let's see, you see it over here on the lower left, we have a table. This basically tells you when your threshold, which is up here is 3.36 feet, when is that going to be exceeded? When is average sea level going to be at that level? And then when is average tide going to be at that level? So obviously mean sea level will be, take longer, but high tide that's going to happen a lot sooner. So that gives you the years. And over here on the table, everything's bound together as well. So you can go by decade and by scenario, almost like in this sort of matrix. And as you do that, it changes the regional contributions. So it shows you that, from vertical land motion, which is going to be sort of a constant, but how the stereodynamic effect, glaciers, Greenland ice sheet, Antarctic ice sheet are going to start to contribute farther out. That has become a much bigger component as you go farther. All right. I'm going to bring up real quick view number 2, but I'm going to do it because we're having a little issue right now today with the API. Co-ops is actually updating that, and we're doing all this dynamically, pulling in the data so it gets updated. But what Quick View 2 will tell you is a little bit into the flood frequency. So it looks at the number of high tide flooding days based on the NOAA high tide flood thresholds that Billy Sweet and others worked on. And this tells you in Charleston that using the intermediate scenario, we've had 19 days of flooding up to this point, but using the intermediate scenario, that's going to be, you see on the little table here, 2050, that'll be about 70 days. So we'll go from 19 to 70 days of high tide flooding. So it gives you a perspective of how flood frequency is going to change over time. Okay, going back to the calculator. This is a particularly interesting quick view here, mostly to try to explain how extreme water level events are going to increase over time. So you'll see right away, you can choose two different sources for extreme water level data. One is the regional frequency analysis, and that's based on a 1 degree grid data from the 2022 tech report. Or you can go back to the traditional GEV analysis that was done by Chris Jervis at all the tide gauges. I'm going to keep it on that for now. And we provide you the max water level over the history of the gauge. And then we have you all the top 10 water levels here, and they're all linked. So if I want to know what Hurricane Irma was, it'll change the threshold right to there, and it'll crosses over the different water level probabilities. So you can see that Irma was probably a 2% event. And then if you go across, you can try to figure out when that will become the 10%. And by 2050, you're going to go from the 2% to the 10%. So that's just showing you how the frequency is going to change over time. You can change the scenarios and see how really the frequency is going to really go up. So that means, even a Hurricane Hugo eventually is going to become, a much more frequent event. So all of the gauges are all tied to these historical water levels. And the great thing about it being dynamic is they're updated as soon as like Helene and Milton, all of those are already in the calculator. And again, it's all tied. The graphics and the maps are all tied together. All right. This is one that also I think is pretty interesting. I'm going to turn off some of the variables here in which you can do. First thing is to see the historical trend in Charleston. We had the gauge operating back in the early 1900s, and I think it was moved and then really started in 1922. You can see that the rate over that time using the linear trend, we've had about 1.44 feet of sea level rise, the rate about 0.14 inches a year. A lot of that, 0.68 feet, was due to vertical land motion. But we can also look at those southeast regional trends. Okay, that's from the NASA data that was included in the 2022 tech report. That shows you that the amount of sea that we've had since 1993 is about half a foot, and the rate has increased too. And then we can also put on the extrapolation going out to 2050 using the best fit starting in 1970, and that'll give us even a higher amount by 2050, almost another foot of sea level rise, and the rate is going to really increase. So, and then it compares it to the global rate. So what this is showing you, and we're going to be adding some functionality to do a hinged trend on some about 33 gauges around the country where the acceleration is high enough, we think, since 1993, that we should be showing a hinged trend instead of just a linear. So point being, I know that in the regulations, and ASCE is looking at, including the long-term trend for future design, but for a lot of stations, around 33 at least, the acceleration we feel is higher than that, and that should be used probably for design because it won't be adequate just to use the long-term trend. Last one I'll show, I don't want to take up too much time, but this has to do with seasonality. This red area is the area that floods at the NOS threshold. And this is just showing that during certain times of the year, obviously in the southeast in the fall, we have warmer water and we have most of our tropical events. That's why we have higher water levels. But if you're doing design and planning for doing projects, it helps to know when the best time of year to do construction is. For instance, marine construction, you'd want to do it in the spring because the water levels tend to be at least almost a half a foot lower on average. And you can look at all the peaks in here as well to see that. And then extreme water levels by month. It also just gives you the month where you're going to see the most high tide flooding days. One last thing, just a little functionality. You can make everything either a dark background or light background. We're going to be working on trying to incorporate a little bit more functionality for downloading the graphs, downloading the data that's coming from the API. And I mentioned we're going to be working on including the analysis from the Cora, which is going to hopefully be on a 500-meter grid, will give us the high frequency events. And that's based on 43 years of water level analysis done by AdCIRC modeling. The Renzi folks up at UNC Chapel Hill have been doing that for us. And we're trying to work with the Corps of Engineers to work on a consistent full distribution from the high frequency events using that 43-year reanalysis, but then also using the coastal hazard system, all of the synthetic storm runs that they do, trying to combine those together, and so that all the agencies can get on the same page with you for these extreme water levels for planning purposes. So with that, I'll stop sharing and answer questions. And like I said, just hit me up if you want a little more detail on any of this.
All right, thank you, Doug. Do we have any questions for Doug?
So, Doug, I have one. Well, I have a statement to make. First of all, I think this is terrific. Thanks for sharing. I assume it's not active now. Is that correct?
It's active.
Is it? Because I was trying to get into it and I'm having a little trouble, but maybe I'll talk with you offline because I'd like to play around with this a lot. I mean,
it should be active.
So I'm from Hampton Roads, and this is critical for Norfolk. I mean, we've got, the double whammy of sea level rise and ground subsidence, and so I would really like to take a deeper dive into this, and also maybe if it's possible, share this with the planning districts around the Hampton Roads area, because I think this is critical information that they all need.
Absolutely, yeah. Do you work with Ben McFarland?
Oh yeah, I know Ben. Oh yeah.
Yeah, Ben was just at our Coastal GeoTools conference, and he's aware of this tool. So yeah, if you need me to do a demo or anything, just get in touch with me. I can do that.
Okay.
And if you're having any issues with it, it should be working. The only one that's not working is QuickView 2 today, and that's just because of an API issue. But it should be working.
Okay, thanks.
Mm-hmm.
Thanks.
Because I was doing it live just then. So,
John, did you have a question?
Yeah, I put it in the chat.
Let's see here.
It is so good question, John. John, good to see you, by the way. We worked with Will Veach on that. So a lot of the functionality we're making sure we're consistent with that sea level analysis tool, SLAT, I think they call it. It's down right now because I think the Corps is working on updates. It's not meant to replace. It's really it gives a little bit of the same functionality, but we're also trying to show on the mapping side as well, and we're concentrating more on like the high tide flood thresholds and whatnot. But we're using the same way we're tagging to sort of mean sea level to make sure we're consistent. That's all going to be the same. So
okay, and does your tool will it show the the relative sea level change or rise at a particular location? We'll give those values.
That's what I was just showing there for Charleston. That's all relative. That's all at the gauge.
Great. That's great.
Yep.
Right. So this tool, especially that it's live, it has all those features, right? So the ASCE 728 Chapter 5 Flood Committee, they've started their work, right? And we know that the 722 supplement to requires consideration of relative sea level rise. The commentary points you to the Army Corps of Engineers sea level change tool. So it would be important for the committee to understand, does this tool complement that? Is it just another tool to suggest for the practitioner to use to meet that requirement? And there's time to do that, right? But it's just identifying that as something to reconcile as 728 Chapter 5 goes through its cycle. Yeah,
absolutely. That's a good point. And
thank you.
Yeah, I mean, and I think part of our rationale is the Corps is using a lot of our NOAA data. This is a chance for us because it's our data to make sure we're curating it and putting it out in a way that we could be as authoritative as possible, and also responsible that it's going to be updated.
Yeah.
So. And
in the same vein, because I've got my cameras. I got my hard copy of ASCE 2424, and that brings over also that relative sea level rise requirement. And so if users of the new 2424 are looking for the data, the tools, the authoritative source, it can make that connection as well as 2424 enters, the practitioner's space. would be a good idea to connect the two.
Yeah. Okay, that sounds good.
Thanks.
And if I can help in any way in that process, I don't know if I'm plugged into all of those, but just let me know. Or are you still working with Jonathan
Yeah.
too, or let Jonathan know, and I'll.
Yep.
Okay.
We'll connect. Let my colleague Jonathan know, and
Yeah.
the folks at Dan Cox and the flood committee, ASCE. So thanks for showing.
Yeah, I worked a
tool.
lot with
Looks really
Jonathan
good.
on the future conditions mapping report a long time ago, the TMAC stuff. Yep.
Great. Thank you.
All right. Thank you both. I think one comment I would make is as soon as this recording is up and posted, I'm sure we can make sure that all the relevant ASCE committees are exposed to it as well. So that'll probably help. All right. Well, thanks again, Doug. Good seeing you.
Yeah, you too. Thank you for inviting me.
You bet. Good work.
Yep.